Hello, Sauce here. This is a pre-calculus video lesson. We're going to develop the idea of average rate of change using data a little bit further. The lesson previous to this was called rate of change from data. Have something to use. I'm going to make a very simple data chart. We're going to imagine that the population of a country was measured and in the millions, and the data we could imagine collecting would be in the year 1970. We may have measured the population of a country to be 12.51 million, and we'll put a second data point for a very simple data set. In 2007, the population is measured to be 20.74. So in a typical analysis, we would have maybe a full table of many data points. This is simplistic for our purposes. The next thing I'm going to do is sketch a graph. There's only 2 points in this table. There's only 2 points on the graph. And the intervals that I'm graphing here are not going to be even, but we want to sketch a simple visualization of what's happening. So this point represents at 1970, the population being 12.51, and the second point at 2007, population being 20.74 million people. Let's label our axes. The horizontal axis is time, and we'll abbreviate population with a P. So what can we do with this? We've been talking about average rate of change. Let's do an average rate of change calculation with this information. First of all, on the graph, the average rate of change, let me spell it out first. This is what we're going to calculate. And how does the graph apply at first to this calculation? Well, the average rate of change would be evaluating how much the population grew. This would be delta P if it's a vertical change. Delta P is the change in population, how much the population grew from the initial time at 12.51 million up to 20.74. And the second value that I need to focus on for this calculation is how much it changed during that change in time. So I can label this horizontal distance between these 2 points with the delta T, change in time. So the average rate of change is the quotient, finding the change in population and dividing by the change in time. This is a slope calculation. It is going to be the delta P over delta T, the vertical change divided by the horizontal change. And typically in algebra, we would label these delta y and delta x. So abstractly, it would be delta y over delta x. And this slope calculation is found by taking the differences between the finishing and the initial amount. So the change in population is the final amount, or the finishing amount, 20.74, minus the initial amount, 12.51. Finding delta T is taking the final amount of time, 2007, and subtracting the initial amount, 1970. So if I find these differences, I have previously with a calculator found the difference in population to find the change in population, and the difference in time to find the change in time. This fraction here can be approximated as 0.222, and this has been rounded to the nearest thousandth. And because this is a contextual problem, it would be appropriate to show units now, million people per year. So this is a positive number. That means that the population has grown, and it's grown on average 0.222 million people per year. Because this is a slope calculation, it would be natural to ask, what is it the slope of? And that is, the answer to that question is, it's the slope of the line that connects the two data points that we just found the average rate of change between. The average rate of change is a slope calculation, and it's the slope of the line that connects those 2 points. Now this is an average because we can probably, when we think of this situation, understand clearly that the population isn't actually growing at that rate at every moment between those 2 years. It's an average because we don't have the data in the middle or between these 2 years to get a more accurate understanding or a more accurate reading of the rate of change. We have just done the most general thing possible with this crude data. We have the amount of change that must have happened continuously through that interval in order to understand how we had a population at this point grow to our only other measurement at a second time. So this is an average. The actual population growth, we do not have the function of, but the function is probably an exponential curve or transformed exponential curve that goes through those two data points. And if we had that equation, we might label it the p equation for population as a function of time.